Okay, we'll close that one off. The third question. All right, just a second more on that one. And then the next one. Here's the last one. Okay, so we'll close that off. Thank you very much for participating in that. And as I mentioned, we'll be running that poll again at the end. Okay, so just before I hand over to Snow, I'll just introduce him. Professor Snow Barlow is from the Melbourne School of Land and Environment, is an agricultural scientist whose research encompasses plant water use efficiency, impacts of climate change on agriculture and global food security. Currently, Snow chairs the Victorian Endowment for Science, Knowledge and Innovation, the Expert Advisory Panel of Department of Agriculture, the Carbon Farming Futures RDE program, and is a board member of the Australian Rural Leadership Foundation. He is a fellow of the Australian Academy of Technological Services and Engineering and the Agricultural Institute of Agricultural Science. In 2009, Snow was awarded the Australian Medal of Agriculture or Science. Together with his partner Winsome McCaughey, Snow operates a vineyard in the Strathbogie Ranges in northeastern Victoria and markets premium wine under the Badajini Run label. So I'll just hand over now to Snow, who'll be introducing both Will and Mick. Are you there, Snow?
Hello, thank you, Heidi. It's a great pleasure to introduce Professor Will Steffen. Will is a councillor of the publicly funded Climate Council of Australia, which delivers expert information about climate change, and also is a global change researcher at the Australian National University. From 1998 to 2004, Will was Executive Director of the International Geosphere Biosphere Program in Stockholm and is still associated with that, the Stockholm Resilience Centre. His research interests, not surprisingly, span a broad range of fields within climate and earth system science, and an emphasis of incorporated human modelling and analysis on sustainability and climate change. Will Steffen.
Okay, thanks very much, Snow. I think we need to click on to show my screen. And then, okay, hopefully everybody can see that now. I'm going to take you on a very quick tour of climate science with the basic science, some of the risks with an emphasis on the Australian rural sector, and then some comments about how the carbon cycle actually operates. So let's see how we can go. This one, okay, so we're not being able to move through the slides, so maybe we have to do something else here.
There we go.
There we go, so we just, right, is that right?
Right, left.
Okay, left click. So 3 parts of my talk, the fundamentals of climate science, and then some of the risks, and then I'll talk a bit about what we call the carbon equation. So let's plunge right into the fundamentals, and this is the change in global average air temperature, the trend from 1850, when we had enough global measurements to get a global average, on up till 2012. And you can see that there's a lot of variability from year to year. That's natural variability in the system. But there is a long-term underlying trend, particularly since about 1960 or 70. We've seen very strong increases in the global average air temperature. The bottom panel shows it, it's averaged decade by decade. So you can average out some of that natural variability. You see the trend very strongly Each of the last 3 decades has been significantly warmer than the one before. But what most people don't realize is that by far most of the excess heat in the climate system goes into the ocean, not the atmosphere. In the 2007 IPCC report, they estimated nearly 90% goes into the ocean. That was updated in the report that was released last year, and it looks like this: 93% of the extra heat since 1971 has been stored in the ocean. And so you can see on that graph there that combining the deep and upper ocean is virtually all of the heat that goes in. Those little wedges at the bottom, the gray one and the brown one and the purple one you can barely see, are the ocean, the land, and the ice. So really all the action is in the ocean. So if you look at the year 1998, when some argue that global warming slowed down or whatever, you can see that in fact it didn't. If anything, it accelerated. But most of that heat is going into the ocean. And as we say, what goes down eventually comes up. So we'll see that will re-equilibrate with the atmosphere in the future. But we see many other changes. Arctic summer sea ice extent is going down, as you can see in the upper left-hand panel. Because the ocean is warming and because we're losing ice, sea level is going up, as you see in the upper right-hand panel. And over the last couple of decades, the rate of sea level rise is larger than it's been since about 1900. Also, in terms of the marine environment, CO2 is increasing in the upper ocean, and that means it is acidifying, which has implications for fisheries and marine ecosystems like coral reefs. We can summarize the changes that we're seeing in terms of increasing temperatures right around the planet in all areas of the climate system. Air temperature is increased, middle atmosphere temperature is increased, air temperature over the ocean is increased, and temperature in the sea surface of the ocean has also increased. We see other changes: ocean heat content's going up, sea level is rising, and we're losing ice. We're losing ice from glaciers on land. We're losing ice from the polar ice sheets as well. So all of this is very consistent with the fact that we have a very rapidly warming climate system. We know the reason for this very well. It's what we call the enhanced greenhouse effect. The greenhouse effect is a natural effect. There are a number of greenhouse gases which are naturally in the atmosphere. The most important of the long-lived greenhouse gases, the ones that are up there for a long period of time, is carbon dioxide. Now, as we increase those from human activities, mainly the burning of fossil fuels, but also from land use change, deforestation, loss of soil carbon, and so on, we're increasing the capacity of those gases to store heat near the Earth's surface. Now, these gases are primarily in the lower atmosphere. That's why you see the heating effect occurring at the surface, on the land, on the ice, in the oceans, and in the air above the surface, and in the middle atmosphere. The upper atmosphere actually is cooling a bit, the stratosphere, and that's because more of the heat is actually being trapped near the Earth's surface. This effect has actually been known for nearly 200 years. It's well established in basic physics. There is no debate, there is no argument about this in the reputable scientific community. And the evidence is stronger than ever that the warming we've been seeing, particularly since the middle of the 20th century, is not natural variability. This is not a natural swing in the Earth system or the climate system. It's driven largely by the increased greenhouse gases in the atmosphere. We can test this by running a climate model actually in the past, not in the future. So if we take the past century, the 20th century, that sort of purplish line that you see wiggling up and down is how the temperature should have changed if it were only natural variability. And climate does vary naturally and by 1 or 2/10 of a degree. Now, if we add in the additional greenhouse gases from human activities, that red wedge is what the temperature should have done. So if you then compare that to what actually happened, that's the black line there, we see that the temperature has risen consistent with the additional greenhouse gases in the atmosphere. So you can only get the observed temperature right if you take into account we're putting more greenhouse gases in the atmosphere. Now, I could go on and on. There's a wealth of evidence to show that this is not natural variability. This is driven largely by human activities. Absolutely no debate whatsoever about that in the reputable scientific community. All right, what are the risks? One of the risks is extreme heat, and this little diagram shows that if you shift the average temperature by a small amount toward a warmer climate, you'll get a much bigger increase in extreme hot weather. That's those colored areas to the right of that bell-shaped curve. you get much more of what we traditionally called hot weather, and you get more record, new hot weather. Now, we can actually see this in the Bureau of Meteorology's statistics. These two bell-shaped curves come from Australian records since the mid-1900s. You can see how those bell-shaped curves on the left-hand side have shifted to the right. That means that we're getting many more warm months than we did in the 1950s, and we're getting fewer cool months. That's the bluey or green-shaped bell-shaped curves on the left. This is one of the more striking graphs I've seen, and this goes back to 1910, and it shows that the very warmest periods, whether they're days or months, the top 1% of the records, which you would expect to occur every 1 in 100, that's what 1% means. So you get 3 or 4 of these days every year, since we have 365 days in the year. And that's basically what you see the first half of the 20th century. But if you look at the second half, particularly since 1970, the traditional 1% is going up in frequency quite remarkably. So that means that the incidence of hot weather is definitely on the increase. If you analyze heat waves, that's not just single days, but periods of hot weather, which is actually more important for agriculture. You see that all sorts of characteristics, the number of heat wave days, how often they're occurring, how long they last, and when they occur, they're all increasing. And this is, again, absolutely consistent with the fact that we're storing more heat in the atmosphere near the Earth's surface. So that means the odds of extreme hot weather, heat waves, are increasing, and that's exactly what we see if we look at the records. What about bushfires? Well, there's a very complicated relationship between climate change and the incidence of bushfires. It affects the vegetation, so it affects the fuel load. It affects how much fuel load is there, and it affects the condition of the fuel load, how dry it is and how prone it is to burn. And those are pretty complicated relationships. But what we look at in general is high fire danger weather. That's where we see the clearest link between climate change and bushfire danger. So that map I'm showing you there with those colored dots, that's what we call high fire danger weather. It's calculated by the Bureau of Meteorology, and it calculates those days where fires are prone to break out. And you would recognize them as being very hot, very low humidity, and very windy. And we can calculate an index. And those circles indicate where that index is increasing around the country and where it's staying static. Most places it's increasing, and the size indicates by how much. Notice that it's skewed toward the southeast of the continent. Most of the high fire danger weather that we're seeing, the increase I should say, is occurring in areas where most of our agriculture is and most of our population lives. The little inset is showing how the trend is increasing at Melbourne Airport. And if we look toward the future, that's again for Melbourne. We see that using projections of temperature increase, we're going to see some pretty sharp increases in high fire danger weather in the southeast, and particularly around Melbourne. Changing rainfall patterns, that's something that's really important for farmers because that's essential for successful agriculture. I'm showing you the trends here since 1970 because they're consistent with a time period where we see the temperature leaving the envelope of natural variability. This is where we clearly see a signal of human-induced climate change. We get some complicated changes in rainfall around Australia. The southwest of WA is getting drier since about the 1970s. We see strong evidence here that there is a climate change signal, so rainfall is not likely to return there. If you look at the far southeast, particularly since the 1990s, we've seen a drying trend there and in Tasmania. There we see some possible climate change signal, but the evidence isn't yet conclusive. We're pretty suspicious, though, because most of that drying is occurring in the winter months, not the summer months. Up in Queensland, you see a strong trend along the coast. There, it's very complicated. Strong patterns of natural variability are still playing a significant role, and we're not ready yet, I think, to make a call that there is a climate change signal. Now, the Bureau recently published some very interesting graphs. This is what's happening to summer rainfall. This is areas where most of the rainfall comes in the summertime. You can see it in the northwest. And what we see there is very strong increases in rainfall over the last couple of decades. These are periods from the 1990s, from 1995, 96 to the present, so roughly 2 decades. So northwestern Australia right into the centre is wetting up over the past 2 decades during the summer season. But if we look at the winter rainfall pattern there, we see that very strong drying trend in southwest WA and in the southeast. And that's, again, consistent with the climate change signal in drying during the cooler months of the year. So, again, we see some quite strong seasonal changes in rainfall patterns around the country. Let me conclude then, because I'm sure I'm running out of time a little bit here, on what we call a carbon equation. And what you see here is that the natural carbon cycle exchanges every year a lot of carbon between the terrestrial biosphere, between soils and between vegetation and the atmosphere in both directions, about 120 billion tons of carbon every year. And the ocean does too, both just from dissolution of CO2, but also uptake by phytoplankton, in other words, by vegetation in the ocean. That's about 90 billion tons of carbon every year. Now, in a natural situation without human emissions, those are in balance, and we've seen that for the last 10,000 years or so, the so-called Holocene, that there's about 120 billion tons that's taken up by the land biosphere through photosynthesis and stored in the soil and in plant biomass, but about the same amount goes back through plant respiration and through soil respiration. So we have a balanced system. Same in the ocean. Now that system is being disturbed by two processes. One is human modification of the land cover through deforestation, through agriculture, which increases the loss from plants and from the soil. But most importantly, we're actually taking carbon that's locked out of that cycle, and that's very important. Fossil carbon that's been stored away from the active cycle and putting that in the atmosphere. Now it's about 9 billion tons a year from fossil carbon. So basically what we need to do to rebalance this is first and foremost reduce emissions of carbon dioxide from fossil fuel. That's new carbon, if you like, being put into the whole system. But we also need to store carbon back into the land biosphere, and that's best thought of not as an offset for the fossil fuel emissions, but rather as a return of legacy carbon that came from the terrestrial biosphere back into the soil and back into plants. So it's very good that we return carbon to the land biosphere, helps increase productivity. It does take carbon out of the atmosphere that was put there originally from land use change, but in the end it can't really solve the climate change problem on its own. So it's a very good thing to do, but it has to be done in addition to, not instead of, or as an offset for fossil fuel emissions. That's basically how the carbon cycle works. That's another way of looking at it, and you can see from 1850 to about 2010, above that horizontal line, that is carbon going into the atmosphere from human activities. And until 1950, land use change was just about as important as fossil fuel emissions. But now the emissions are absolutely dominated by fossil fuel emissions, plus about 10% from tropical deforestation. Below the line shows where that goes. Only about half of that carbon ends up in the atmosphere. The other half goes into the ocean and the land in about equal amounts. So storing carbon in the land is very important. Nature does it. About 25% of our emissions go in. But we can augment that, of course, by things like the Carbon Farming Initiative. I'll conclude by looking at the carbon budget in the future, and this goes back to one of the questions that you were asked in the poll. It's policies of nearly every government around the world, including our government, to stabilize the rise in global temperature at no more than 2 degrees. We're approaching 1 degree now, so we're about halfway to that target. Now, scientists, given that policy target, can then calculate what needs to be done to reach that target. And those two lines you see in the top panel are two different emission pathways. One is with no effective policy, that's the red line, with emissions keeping going up. The blue line is where you see emissions stabilizing by about 2020 and then going down toward the end of the century. And if you actually calculate how much we can emit, that's about 1,000 billion tons of CO2 until about 2050. And that's to stabilize the climate at or below 2 degrees. And that's what we call the carbon budget. So basically we have about 1,000 billion tons of CO2 we could still emit. So the issue here is that we don't need to stop emitting tomorrow. This is a long-term problem, and to do it in a way that's economically less disruptive, we need to phase it out in a considered fashion. But we do have a budget, just like a household budget, or if you have an annual budget, you know that you have to manage that budget pretty carefully. So we need to manage our carbon budget carefully as well. So these are, by the way, our emissions of CO2, primarily from fossil fuels, but from also from land use. So by bringing carbon back down into the land system by carbon farming, you're actually helping humanity meet this budget. So how are we going? That budget starts from the year 2000, so we're 13 years into the budget. We're just starting into 2014. And we can calculate what we've already done to the budget, and we've emitted nearly 40% of the budget. I think we've emitted 392 billion tons of CO2 since the year 2000. So basically, we're spending the budget a bit too fast. And if we keep spending it like we are now, we will use it up by the year 2028. And has to extend to 2050. So that means we really do need to get emissions down. We've only got 60% of the budget left, and we have 37 years. We've got to stretch that out. So we need to start emitting far less from the industrial sector. Now you can do some fairly simple maths. With 600 billion tons left, you can look at how much fossil fuel reserves do we have around the world. That's coal, oil, gas. And it also includes the non-conventional, like the coal seam gas here in Australia, the oil shales in Canada, the shale gas, as they call it in America, and so on. If you were to burn all of that, we would emit nearly 3,000 billion tons of CO2. And you can do the maths. Our budget's about 600. That means we can only burn about 20% of the world's known fossil fuel reserves. Most will have to stay in the ground. So the big ticket item actually still sits in the industrial, the energy sector, the fossil fuel sector, but that's not to say that it's not important that we get more carbon back into the landscape. It is important, because if we don't, we're going to have even more limitations on fossil fuel emissions. So we have to do both, but the bottom line is let's get both emissions down as fast as we can. Last slide. I'll just show you those two temperature futures, and I'll make this a little bit personal as I close. This isn't my slide. It actually comes from Professor Leslie Hughes from Macquarie University. So she makes this personal by putting, putting her lifespan on. Let's see if I can do this. There it comes. That line that says me. That's Leslie. She was born in the 1960s, and she'll live to about the 2050 or so if she lives out to an average lifespan for an Australian woman. And then she puts that at the average temperature she'll experience, somewhere between half a degree and 1 degree above pre-industrial. All right, that's getting a little bit warmer, but certainly manageable. She has 2 children. Her children were born in the 1990s. If they live out their average lifespan up until the 2080s or so, their average temperature would be just above 2 degrees that they would have to cope with. But when they get to be my age, and I'm in my 60s, their temperature would be way up around 3 or 4. This would be really difficult to live in. Leslie doesn't have grandkids yet, but she'd like to have grandkids, and they would live into the next century. So when people talk about 2100 being meaningless in terms of the time frame we consider, well, it really isn't, because most people can think 2 generations. You certainly think of your children, and you can think of your grandkids. So the whole reason that we need to have effective climate policy is to move that temperature, let's see if we can get that to come down, there we go, from way up into the 4 or 5 degree level back down to below 2 degrees, so that our grandkids have a climate they can actually cope with. So it is important. We do need to take a long-term view. Storing carbon in the landscape is important. It's part of the equation. And the nice thing about that is it gives other benefits as well. It improves productivity, can help biodiversity, can do a lot of things. So it's an important part of the carbon equation. And I'll stop there, and you can read what the key messages in my presentation are. And thank you very much for the opportunity of presenting a bit of science.
Thanks. Over to you.
Yep. Okay, so I'll just bring the screen back to mine. Snow, if you'd like to introduce Mick, that would be great. Thank you very much for your presentation, Will. That was fabulous.
Thank you, Heidi. It's a great pleasure to introduce Mick Keogh. Mick was born and raised on a farm in southern New South Wales. He studied at the University of New South Wales, earning both a bachelor's and master's degree in agriculture. He has worked in quite a broad range of areas in agriculture, including as a farm manager, researcher, agribusiness consultant. But in 2003, Mick was appointed as the inaugural, but the only, executive director of the Australian Farm Institute, which is an independent policy research institute which conducts research into the strategic policy issues of importance to Australian agriculture. And for any of you not familiar with the AFI, it has produced a number of quite pivotal policy papers around Australian agricultural issues, and quite a few indeed around climate change and mitigation on farm as well. In 2011, Mick was appointed the chairperson of the Australian Government's panel to review drought support measures, which provided a fundamental change in Australian drought policy in 2012. And more recently, Mick was appointed as chair of the National Rural Advisory Council, which is a statutory council whose job is to advise the Minister for Agriculture on policy issues. It's a great pleasure to introduce Mick Keogh.
Mick, you'll just need to click on to show my screen. Are you there, Mick? Okay, just bear with us for one moment. We seem to have lost Mick. All right, I'm sorry about this, everybody. Mick, are you there?
I don't see anything yet. I hope we got that right.
Okay, we've just lost your audio, Mick. I apologise about this. Just checking, Snow, you can't see Mick's screen, can you?
No, I can't see Mick's screen.
All right.
I don't know how I get that up. Back up again.
Okay. Oh, is that Mick there?
There he is.
It's up.
Can everybody see that?
We can.
Okay. We just can't hear Mick, so just give me one more second.
I don't think we can click Mick's full screen.
No. Okay.
I've just come back.
Oh, there we go. Beautiful. All right. Over to you, Mick.
The building here, my apologies, the building here seems to be losing internet.
Okay. Well, we'll see how we go. Yeah. So if you want to maximise your screen, Mick, and then click on show screen.
You're right there or not?
No. We're not seeing it. I'll just change it back to me.
I'm experiencing network connection difficulties.
All right. The alternative is I can bring it up on my screen and you can talk to it, but you'll just have to tell me.
Can you see it now? I'm up there.
No. My apologies for this, everybody. I'll just bring it back to my screen and then we'll go back to yours again. Okay, try again now.
Do I click show my screen?
Yes, that would be great. Okay, we can see you now.
Got me now?
Yes, thank you so much for that. My
Okay.
apologies, everybody, and over to you.
Okay, well, Will's been talking to you about the science of climate change. Now we're going to switch the discussion around a little bit because we've got to talk about the policy of climate change. Will's been talking about what the science suggests needs to happen in a policy sense. Now we're talking about the reality of that. How do you make that happen? So the first bit we'll talk about is carbon policy as we know it at the moment. And of course, I'm sure you're all aware that the intention from the government is that that will change shortly after July 1 this year. So it's useful as background, but just be aware of that. We'll then talk a little bit about carbon markets and prices. The Carbon Farming Initiative is the mechanism used to engage agriculture. So we'll talk about that a little bit, and then talk about some business implications, and hopefully conclude with some messages. So as Will said, you've talked about the carbon cycle, which involves the atmosphere, the soil, the water, and the problem being that too much of greenhouse gases are being released into that pool of carbon in the atmosphere, and that's creating the greenhouse effect and creating an increase in temperature. What we also need to remember, though, is the other half of that cycle, because that's where agriculture comes in. So things like vegetation, soil, and animals remove carbon from that pool. So when we're talking about policies or measures to reduce the pool of greenhouse gases in the atmosphere, we've got two possible mechanisms. One is what's referred to as emission abatement or mitigation, in other words, reducing that amount going into the pool. The other is sequestration, speeding up the amount that would otherwise come out of that pool. So in all of this discussion, you have to remember that there's two sides to the story when it comes to policies to reduce emissions in the atmosphere. One is mitigation, reducing existing emissions. The other is sequestration, speeding up the locking up of some of that extra greenhouse gas into forms where it's not in the atmosphere. Okay, so what we've got at the moment is the Clean Energy Futures legislation. It aims to reduce emissions by requiring large emitters to pay for an emission permit for each tonne of emissions they produce. And the Carbon Farming Initiative is the other side of that equation, and that it aims to create incentives for farmers to undertake projects to reduce atmospheric greenhouse gases, earning an emission permit for each tonne of emission abatement. So this is the current policy, and then the two are linked, because obviously the emitters that we're talking about up here need to purchase permits, some of which can come from here when they participate as they're required. So the emitters are required to participate mandatorily at the moment. Farmers can volunteer to participate if they want to, and sell those permits that they earn to those major emitters. So in talking about this whole issue, there's a couple of points to keep in mind. The first is that we talk about carbon, but what we're actually talking about is a collection of greenhouse gases. So there's 6 greenhouse gases. Each of them have different warming potentials, but the shorthand to talk about them all is carbon. And so what we actually mean when we talk about carbon is the combined warming effects of those 6 gases expressed in terms of the warming effect of carbon dioxide. So to give you an example, 1 tonne of nitrous oxide in the atmosphere has the same warming potential as 298 tonnes of carbon dioxide. So it's called, it's 298 tonnes of carbon dioxide equivalent. That's what that -E means there. The same with methane. Methane CH4, and it's 25 times as potent as a greenhouse gas as carbon dioxide is. So 1 tonne of methane in the atmosphere is equivalent to 25 tonnes of carbon or carbon dioxide equivalent. So it is important that you understand, particularly from an agricultural perspective, that it's not just carbon and carbon dioxide we're talking about. It's actually a range of other gases, and two very important ones for agriculture are nitrous oxide and methane. And so when you hear carbon traders talking about carbon, they're referring to carbon dioxide equivalents, which can be made up of a combination of those different gases. Okay, the other side of the issue that we need to talk about is the fact that, as you could understand when you stop and think about it, there's no such thing as a greenhouse emission meter. You can't actually measure most of the greenhouse emissions that are created because, as Will has said, they're created by all sorts of things: trees burning, pasture breaking down, petrol burned in cars, the enteric fermentation of ruminant livestock, etc. So most of the discussion that we have around trading in carbon relies on a set of rules, a set of accounting rules. So this is the sort of thing that we do. So rather than trying to put an emission meter on every car, the estimate is made that 1 litre of petrol that's consumed or burnt releases 2.3 kilos of carbon dioxide equivalent. So simply the measure is how many litres of fuel did you use, and from that the estimate is made, well, that's how much carbon dioxide equivalent emissions you produced. Diesel, coal, etc. So the main thing is that there's this whole set of rules that underlie carbon accounting, and that's what needs to be understood when thinking about the carbon market and how it operates. And also the second thing is that a carbon market is one created entirely by government and subject to rule changes as governments see fit. So carbon markets are subject to this thing called sovereign risk, which doesn't necessarily occur in a lot of other markets. That's quite an important thing to keep in mind when contemplating participating in this market. So if we look at our carbon policy as it exists at the moment, the Clean Energy Futures Act made it illegal for large emitters producing more than 25,000 tonnes to release emissions without a permit. Those permits were initially priced at $23 and they've gone up about 5% a year since then. It was to be transformed into a market-based emissions trading scheme, so rather than having a fixed price in 2015, it was simply going to be based on a limited number of permits without a set price. So the government would release those permits and people would bid for them depending on the supply and demand. And it was also to be linked to the international carbon market from 2015 with a 50% limit on how many permits businesses could buy to meet their emission requirements, mainly the EU carbon market. And some of the exporters were to receive free permits. And agriculture, the direct emissions from agriculture were to be excluded. In relation to fuel, as we said earlier, you know how many emissions are created by burning a litre of fuel. So the way it was to be applied to fuel was to apply a tax of around about 6 cents a litre on the price of fuel. But fuel for non-commercial vehicles was to be excluded, fuel for airways, railways and mining, a tax from 2012, heavy vehicle diesel tax from the middle of this year, so that 6 cents a litre price would apply to heavy vehicle fuel use from the middle of this year, and farm, forestry and fishing to remain exempt. And those are all to be reviewed, which of course is the case anyway, because the government's proposing to rescind that legislation and replace it. So the alternative policy that the government is now talking about is what's called the Direct Action Plan, and it's basically a tender-based policy. So in other words, instead of requiring those businesses to count their emissions each year and then buy permits, what it's proposing is that the government would have a pool of money there and go to the market and say who's prepared to reduce their emissions and what price per tonne of emissions do you require in order to go ahead with that. So that is the basic difference. Whereas in the previous policy, all those businesses had to participate, had to count their emissions each year, and then buy permits to offset those emissions. Under this arrangement, it will be largely voluntary, or not completely, and the government will be the buyer in the marketplace, if you like, of emission reduction arising from projects that businesses decide to undertake because it makes commercial sense. It's also proposed there will be pretty strong reliance on soil carbon sequestration, or I think those expectations have changed a little bit, and there's a baseline and credit system in place. So in other words, how you measure your performance in terms of producing emissions or reducing emissions is to start with a baseline. You start from what you do at the moment, and then create a credit for any reduction that you can achieve from that baseline, which is another difference from the previous scheme. So if we look at an emissions trading scheme as it exists at the moment, the government determines the coverage, the number of targets, the number of permits it's going to release, and the target. Those businesses have to estimate their emissions and reduce them if possible. The options they have are Australian emission permits, which the government issues, permits from offset projects like the Carbon Farming Initiative, or permits from international projects. So a company might say, well, look, our total emissions are 30,000 under the existing scheme. That means we have to participate in it. But I've bought 3,000 permits from farmers under the Carbon Farming Initiative, and I've got another 10,000 I've bought internationally. So that means I've got to go and buy 17,000 of those government permits at $23. They would then go and do that. They would then do their accounting at the end of the year. If they had spare permits, they could sell them. If they didn't have enough, they might have to go back into the market and buy them. And then the cycle would continue. And what the government intended under that scheme was to gradually reduce the supply of permits, which would of course increase the price and make it more financially attractive, if you want to put it that way, for those businesses to reduce their emissions. Part of that, as we saw, was a provision for farms to be involved. Farms don't have to pay for their emissions, but the mechanism for involvement was that farms could undertake projects that were recognised as reducing emissions and sell that reduction in emissions via permits to participants in that emissions trading scheme. The complication here gets back to the discussion I had earlier about accounting, because not all emissions are created equal. For a range of rules, mainly associated with international agreements, for a range of reasons, sorry, mainly associated with international agreements, there's rules around carbon accounting. So, if a farm undertook a project that involves eligible forestry, in other words, growing trees that could be recognised, or reducing emissions from livestock and nitrogen fertiliser, or not cutting down trees that someone had a licence to cut down, then they're recognised under the international accounting system as what are called Kyoto credits. And so they can be sold into the mandatory carbon market that exists in Australia at the moment. However, there are also non-Kyoto Protocol offsets. In other words, actual emissions reductions that can occur but aren't recognised by the Kyoto accounting rules. And soil carbon has fallen into that category up till now. So soil carbon isn't included in Australia's national greenhouse emissions inventory and hasn't been recognised as a Kyoto Protocol offset. Therefore, up until now, it hasn't been able to be sold. If you could do a project on soil carbon and you wanted to sell the credits, you could only sell them into the voluntary market. That's the market created by individuals who choose to offset their airline flight emissions, for example, or companies that want to make carbon neutral claims, or sometimes the government might purchase some of those emissions. But that is subject to change in 2015 when a new set of international accounting rules will come into place. But at this stage, it's not certain whether you'll be able to sell those credits into the official carbon market that's going to be established by the government's emission reduction fund under the new legislation, if and when the Senate approves that. So let's just think about this market that farmers can potentially get into. It's a market like every other market where prices are set by supply and demand. So in current terms, the biggest market globally for carbon is the EU carbon market, the official EU carbon market. And you can see from this graph, which is expressed in euros per tonne, a euro at the moment is the equivalent of 65 cents Australian. So to do your conversion, about 1.5 times the euro is the Australian dollar. So you can see here that currently, as of in fact the last few days, the European carbon market is trading at about $10 a tonne Australian. So, but also it's worth noting that of course at different stages it's been down around $3 or $4 a tonne. So it's not a steady price, and that's the major difference in a traded market compared to the market that's applied in Australia up until now, where the government's been setting the price at a fixed price of $23 plus 5%. So first thing to notice or to think about in considering participating in an emissions trading scheme is in fact that it's a market like every other market, and prices go up and prices go down. So we look at some case studies under the Carbon Farming Initiative. There's a range of methodologies, so you have to follow the recipes to be credited under that scheme. There's a range of key requirements associated with them. What you're doing has to be extra. You can't get a credit for doing something you're always doing. Where it's a sequestration project, you have to be able to prove you've locked that carbon up in the trees or in the soil for 100 years. No leakage. You're not supposed to be able to get a credit for doing something good on one part of your property that results in something bad on the other part of your property. Your project and your methodologies have to have validity and be measurable, and conservative assumptions, and audited and verified by a third party. So that's the rules that exist at the moment. There's a range of these methodologies, or recipes if you like, available. These are ones that have been signed off, and so they give you some idea of the sort of different projects you can undertake. They range from reducing the greenhouse gases coming from livestock manure and livestock waste, through to different actions on timber and vegetation, and even to landfill and waste management by council. Is not really something that farmers would get involved with. There's a whole range, and some of these have actually probably been verified now and are actually methodologies, although the soil carbon one hasn't. So there's still no soil carbon methodology as I understand it, but there is one, I think, for the oil consumption by cows that reduces their methane emission, and a range of other ones. So the way your project would work is, if you agreed that you're going to plant a tree plantation, for example, you'd plant trees. You do have to check a couple of things about rainfall, because they don't want trees to divert too much rainfall. And if you're in the higher rainfall zones, you may need, under the current rules, to buy water entitlements. You'd plant the trees. At some point, somewhere between 3 and 5 years, you'd have someone come and audit those trees. Once they've approved that audit, you would then get permits added to your permit account, much like shares in a share account. As time goes on and those trees grow, you keep getting more permits credited to your account. Once those trees reach maturity, of course, under the rules at the moment, you have to maintain them there for 100 years. So you still have to undertake the periodical audit, but you're not getting any extra credit. If you did decide to cut them down, then you have to pay those permits back. And of course, if the price of carbon had gone up compared to what you sold those permits for, you would be out of pocket. Under the rules at the moment, if it's a natural occurrence that resulted in the trees being removed, like a bushfire, you don't have to pay the permits back. But what you do have to do is replant those trees, and you don't get any more credit until those trees exceed the maximum stock of carbon that you've been credited with. So quite a few issues you need to think about there. Soil carbon is essentially the same. Say, for example, you'd run down soil carbon and you decided you were going to create a project by putting a paddock back into permanent pasture. Presumably the soil would build up and the fertiliser would keep increasing that soil carbon over time, but you would have to make sure you maintain that soil carbon there, just the same as you have to maintain the soil, the trees, and that's quite an important thing to think about. There are some mitigation projects around dairy and piggeries. These are different because they're on that green side of that initial graph that I showed you. In other words, the mitigation side, the red side, then you don't have to maintain these credits or maintain the project multi-years. If you do it 1 year, you get credit for the emissions you've avoided in the 1 year, and if you then continue the project next year, you get credit for those. So quite a different thing from having to lock up carbon in soil or trees and leave it there for 100 years. The way it works, you might, for example, digest manure from a feedlot. That produces a gas. You can either burn the gas off, or and that generates carbon credit units, or you could use that gas to run a cogenerator. You could feed that electricity into the grid, and you could earn both Australian carbon credit units, the ACCUs. You could also get a tariff for supplying electricity, and you can also generate what are called LGCs or RETs, so they're renewable energy certificates, and they're worth money as well. So you could also just use the gas to run your own generator and power the feedlot, in which case you'd also still get ACCUs, Australian carbon credit units, and the renewable energy certificates. So you can see that in a project like this, where you've got multiple products coming into the project, that's a fair bit more attractive than a project that's just producing carbon credits. And that's why piggeries in particular have been quite quick to jump onto these sort of projects, because in many respects this bit here pays for the project. It's good enough, the revenue generated here and the savings generated here pay for the project, even without the potential value of the renewable energy certificates or the carbon credit units. So those projects have gone ahead. There's obviously project costs involved in setting them up. We've done some modelling when we looked at trees, and I'm sorry to rush these, but I'm aware of the time. We found in a high rainfall zone we could get 20 tonnes per hectare of sequestration. Depending on the carbon price, that was your sort of payoff time for the project. By the time you expended the $2,000 a hectare to plant the trees and paid for the accreditation and those sorts of things, under a high carbon price you were back to break even by about year 6, but under a moderate or a low carbon price it was going to take a fair bit longer to pay off. And that low carbon price, if you go back to the previous graph, sorry, I'm mixing it up there, but it was certainly around that sort of $5 a tonne. So it's going to, at that sort of price, it's going to take a fair while for that project to pay off. Sorry, I'm going the wrong way here. My apologies for that. Farm business implications. There's a number of different ways you can participate as a direct sale. In other words, you sell credits to traders. You get a broker or an aggregator who arrange your project, or you lease your land to someone who's running a project, and they set it up on your land. And there's also pool credit arrangements where you might be part of a catchment group that puts credits together and sells them as part of a pool. Each of those has different pros and cons. If you're involved directly, you want to make sure you've got a market for your credits, and that's the biggest issue at the moment. We're not sure what's going to happen to those credits, so you could have incurred all those costs associated with setting up a project and not really have a market for the credits. Of course, the cons of that sort of a project are if you set it all up yourself, you get to run it and look after it and make sure it's all working. So in that respect, it could be attractive. where you get an aggregator. In other words, you pay a professional and you get a share of the credits. They obviously run it. If they run it wrongly, it's still your problem. A bit like an agent selling your livestock. If there's a problem with the livestock, it's still your problem. So there's some issues there, but it could, rather than you having to learn all the rules and all the ins and outs of how it works, at least you'd have almost a consultant involved that would manage it for you. A land lease arrangement, that's certainly been the one that has been used a bit in places like WA. The issue is very much that you are still responsible. So in the event, for example, that the aggregator or the lessee goes broke, if he's earned or she has earned credits for that project, you are still responsible to maintain it. So even though you may not be getting a payment because that aggregator's gone broke, and this is what happened in Canada, you've still got to maintain the trees on that area. So certainly that needs to be treated carefully. Just some quick sum-up messages. The CFI might provide an opportunity to generate offset revenue, but I think it would be almost certain that you would want an off-take agreement. In other words, you would want someone committed to buy the credits you were able to generate from your project before you undertook a project. Or alternatively, if you're, for example, involved in piggeries or dairy, you may well go down that project path simply because it made financial sense to do so anyway, because of the reduced electricity costs or the benefits you might be able to generate through a feed-in tariff. At this stage, I think it would be fairly risky to undertake a project like this without actually having a market already in place for the credits you're going to generate. And it's actually, there's a big question applies at the moment in relation to the direct action program, because the emission reduction fund is going to be a tender-based process where you offer the credits that you have available at a fixed price, and if they're the cheapest price credits that are available, the government buys them, at which point you're then committed to deliver them. So the challenge is, do you set your project up first, and then once you know that it's been accredited and underway, offer to sell those credits? But the risk that way is, of course, you don't know what price those credits might be because of the way the tender is going to work, which is a reverse auction system. So a lot of uncertainty around that at the moment. Certainly, if you're in a project in a piggery or a dairy, the situation is different. But for a tree planting or, for example, a soil carbon project, if the methodologies came up, I think you probably need to make sure you had someone buying those credits that you're able to generate before you get started. Just a message to these projects are new enterprises. They're like a grain grower taking on wool production, or a dairy farmer taking on prime lamb production. You won't get it right the first time, so there will be learning required in getting those enterprises up and running. Permanence under the new policy, if it's implemented by the government, that permanence requirement has dropped back to 25 years, but it still means that if you're in a soil carbon or a tree project, once you're into it, once you're locked in, once you're earning credits, you can't remove those sequestered carbon for 25 years. So those trees stay there, or your soil carbon has to stay there for that sort of length of time. And at the moment, there is still talk of a voluntary market for offsets that aren't really recognised under the Kyoto Protocol, but it's not sure what's going to happen to that when the legislation that's in place at the moment is either repealed or modified after the Senate changes in July. So quite a deal of uncertainty at the moment, but as I mentioned before, the mitigation projects for example, a piggery or a dairy are certainly worth looking into, and we've seen some of those going ahead and generating some benefits for the farmers, in addition to what they were getting from their enterprise anyway. So certainly a start has been made in that regard. Just a final message from the sponsor. The Farm Institute has an online calculator which is very handy, and it's free, and it can be used to get some sense of the sort of emissions and the emissions change that might be able to be generated by projects under the Carbon Farming Initiative. So if you're interested, have a look in that. It's on that website on the bottom, and that allows you to work out what sort of carbon offset numbers or credit numbers you might be able to generate from a particular project. Over to you, Heidi.
Okay, thanks so much for that, Mick, and thank you to everybody, including Mick, for putting up with those technical issues that we had at the beginning. We do have 2 or 3 questions, so if people have the time to stick around for that, that would be great, and I'll hand back over to Snow to answer or to drive those questions. So over to you, Snow.
Thank you. The first one, the first question is for Mick, which is why does the EUA, in fact the European carbon price change? You know, what are those drivers? Mick?
Okay. The EU carbon market is a different one to the one that currently operates in Australia. The main difference is that under the EU scheme, businesses that were required to participate were initially required to estimate the emissions that they produced and were then allocated permits for free in order to pretty much meet their current emissions. So if a business was producing 100,000 tonnes of emissions, then they were pretty much issued with, for free, 100,000 emission permits, which they then had to do their accounting for. Obviously, if they increased their emissions, they would have to buy more permits. If they reduced their emissions, they would have spare permits that they didn't have to hand in at the end of the year. Now, to put a polite phrase around it, it's probably fair to say that some of those companies participating in that scheme when it initially started overestimated the amount of emissions they produced, and therefore were allocated with a lot more permits than they probably needed, and that created a fairly large pool of spare permits that weren't really needed by those companies and were available for sale. In fact, it got up to 2 billion tonnes worth of extra permits. The EU, and that of course led to, if you go back to that slide, that led to that progressive drop in the price of carbon, which got to the bottom sometime in 2013. At that stage, the EU authorities said, look, we can't survive here. We're going to lock up some of those and not allow those companies to put them onto the market. And they'll only be able to trickle them onto the market slowly. So once they did that, once they restricted the ability of those companies to put all those spare permits onto the market, gradually you've seen a recovery in the price of carbon in the EU market up to $10. So it really does highlight the fact that when governments set rules for these markets and then change them, it can bring in this issue of sovereign risk. So it is important to understand and to look at risk management when it comes to potential prices for carbon into the future. So it's a very good lesson about markets created by government and the extra risks they have associated with them.
The question is how ready the agricultural industries, when plotted on a marginal abatement curve against an expanded, less land-based emissions reduction options under the new reverse auction type emissions reduction fund. In other words, basically, I guess what the questioner is asking, how competitive do you think the agricultural industries will be under an emissions reduction fund?
that's a very big unknown at the moment, and it's a very good question. On the numbers that we've done, and the Institute's done a fair bit of modelling of projects and budgets, we estimate that somewhere around the $30 a tonne, a tree project is competitive with existing enterprise options in medium to high rainfall, so above, say, 600 mils of annual rainfall. So at that $20 to $30 a tonne, if you've got trees there that are sequestering at a rate of about $15 to $20 tonnes per hectare, then your gross margins per hectare are around about that $400. So that's reasonably competitive with some other enterprises, so running merino sheep, for example, or running trade cattle. And so we reckon that that's probably about the price mark where a tree project, for example, would be competitive. And what we don't have any clue about at this stage is what the likely prices are that will be bid in that tender that the Emission Reduction Fund will hold. It's suspected that some of the major electricity generators and major emitters will have some pretty inexpensive options available to reduce their emissions, and probably come in well under that $23 in the initial rounds. Now, how long those sort of cheap options are available and how quickly it moves to a higher price because those easy options dry up is very much an open question at the moment and not known. So on that basis, it will take a while for a tree project to be competitive. Soil carbon, a different question. If there is a soil carbon methodology available under the CFI, and if it's not a hugely expensive exercise to bring up soil carbon, it may well be that because you can also run a grazing enterprise, for example, in conjunction with measures to increase soil carbon, it may well be that those sort of projects would come in, you know, maybe as low as $10 or $15 a tonne, and they might be competitive at an earlier stage than, for example, the trees would be. And then going back further, as I said in the discussion, the mitigation projects associated with piggery waste or dairy waste are actually competitive now, even ignoring the potential value of carbon. So they may well come in quite low as well if someone's got those projects running and have got some carbon benefits generated by it, and may as well put that on the market for whatever price is available. But there's not a lot of them running. Obviously, we haven't got a very big piggery or dairy industry in terms of the numbers that might participate in that. So I think that's probably the sequence we'll see, that some of those mitigation projects will put whatever spare credits they've got into the market, because it's all win for them, whatever they get for them. Then the next sequence might be, if we get soil carbon up, and you can do it in conjunction with a grazing enterprise, you might see it as just an added benefit, as long as it doesn't cost you too much to run that project. And then trees are probably going to come in at a later stage when, or if the price is, you know, in that $20 to $30 a tonne region.
I think we've got time for one more question, Snow.
Okay, thank you, Heidi. I think the question will go to, you know, have there been any advances redeveloping offset methodologies for fertiliser, primarily reduced nitrous oxide emissions? And really, Mick, I can just add a little bit at the beginning. I'm sitting in the Department of Environment at present, and that's what I've been doing here this morning, part of a consultation there. And there are some nitrogen fertiliser methods that are in the mill at present, but one of our discussions today was about, you know, how we could unstick them and begin to move to more methodologies around the use of nitrogen. But over to you, Mick.
Yeah, well, I think I don't know that I'd add too much more. The three options available. One is what's called coated nitrogen fertilizer. So that's coated with a water-resistant coating, which means that it becomes a slow release thing, and that's known to reduce emissions. The second is injecting nitrogen fertilizer through things like irrigation systems in orchards, although they're not big producers of emissions, or through tillage systems, layering it under crops in the ground, and that's understood to reduce emissions. The third thing is all about timing of applications in relation to rain. So in other words, undertaking QA systems where you don't apply nitrogen fertilizer the wrong side of a rainfall event or anything like that, and that's also known to reduce emissions. That latter one is obviously pretty difficult to think about in terms of a methodology, but there are some bits and pieces floating around, but nothing. I think Snow's answer might be the correct one. There's nothing actually there at the moment where it's clear that you could undertake that and get some credit for it.
Okay.
Thank you. Probably back to you, Heidi. You have to close up.
Yeah, I will. Thank you. Thank you, Snow, for chairing the session and for chairing that question session. Thanks also to Will and Mick for taking their valuable time to share their knowledge and experience with us throughout the webinar. I'm sure everyone will agree it's been fantastic and very valuable. For everybody's information, this webinar will be uploaded to the Young Carbon Farmers YouTube channel. We will have links from that from the Future Farmers website, the website address that you see at the top of that slide. That should be uploaded next week. So if you wish to receive it before then, please send me an email based on the registration email address that you should have. We will be conducting our first carbon bus tour next week, where participants will get really unprecedented access to climate change and carbon farming experts, scientists and farmers. The first tour is in Queensland, in Townsville and Charters Towers, but there will be a second tour in Victoria in September. So if you would like to apply to be one of the 10 funded participants on those tours, please again go to the Future Farmers website, and applications for that close on the 7th of July. Thank you to everybody again for attending and participating in the webinar. I apologise for the technological issues that we had. Internet is a fabulous thing when it's working. So I will say goodbye for now. Please participate in the poll at the end of the webinar, and have a great rest of your day.
Thank you, Heidi. Bye.
Okay, bye-bye.